So in lesson 4 we look at Inter-VLAN routing. The main objective of this video is to show you or demonstrate to you how you can configure Inter-VLAN routing using the two methods. That's a router on a stick, or sometimes referred to as roast, and using a layer 3 switch to configure Inter-VLAN routing. So this video is going to follow on with the module 4 PowerPoint slide. Again, you can have a look at the notes yourself, read through the notes. What I'd like to do here is basically to summarize these two main ideas, because that's basically what this whole module is all about, to introduce you to these two methods of configuring Inter-VLAN routing, the differences between the two. So if you look at layer 3 using router on a stick or roast uses sub interfaces, and it uses a router. The Cisco IOS router Ethernet interface is configured to function as a trunk interface. So it does some tagging, 802.1q tagging. It's connected to a trunk port on a layer 2 switch, and for every VLAN that is on your network, you use sub interfaces. So for example, if I have VLAN 10, 20, 30, I will create, if it's interface G01, I will create G01.10, G01.20. So each interface, each sub interface will be created corresponding to the VLAN. Okay, so this will facilitate a form of logical routing. Now again, notice the word logical routing there simply means that router on a stick is configured, or the sub interfaces are configured based on software. So it's software based virtual interfaces, and anything to do with software based virtual interfaces, there are some limitations that come with it. Okay, so in terms of sub interfaces, you cannot go beyond or scale beyond 50 VLANs. Although you can create the sub interfaces and start assigning IP addresses to them, configure trunking so that each VLAN has its own default gateway, and you are able to have VLAN 20 communicate with 10, or vice versa, 30 communicating with 20, and so on. It's all software based logical routing, and one limitation is that router on a stick does not scale well beyond 50 VLANs. So one method to overcome that limitation with router on a stick is where layer 3 switching comes in. So sometimes known as multi-layer switching, but for the purpose of this module, we're going to refer to it as layer 3, specifically because the switch here is going to perform a layer 3 function. It's going to do a routing functionality. Okay, so when you look at layer 3 switches compared to router on a stick, they're much faster than roast, again because everything is hardware switched and routed. So it's hardware based, unlike roast, which is software based. There is no need for external links from the switch to the router for routing. All you do is you use the existing interfaces, the Ethernet interfaces. You just need to turn routing functionality on, turn them into routed ports so that they're able to do routing functions. They're not limited to one link, again, because layer 2 Ether channels can be used both as trunk links to increase bandwidth. Latency is much lower, okay, again because that data does not need to leave the switch in order to be routed to a different network. The switch does the routing function also. It does switching, it also does routing as well. So they are more commonly deployed in a campus LAN than routers. But then the only disadvantage about layer 3 switching is that layer 3 switches are a bit more expensive. Okay, so in this video is where we now go into configuration. Okay, so I will stop here. If you download the packet tracer file that comes, lesson 4 packet tracer file for this video that accompanies this video, you will notice I have put in the configs there. Okay, so we're going to, it's the same network we used in lesson 3. So we're going to take that network, add a router, configure router on a stick, and test if VLAN 10 can communicate with 20 or vice versa, 20 can communicate with 30 or vice versa. So we want to see that it's not just intra-VLAN. Remember, it's not just 10, 10, 20, 20 to themselves, but we now can see different VLANs are able to see each other through inter-VLAN routing. So we'll do roast first. Once we test and we verify everything is okay, we'll remove the router, and then we'll connect a layer 3 switch, and then we'll try configuring layer 3 switch with inter-VLAN routing. Okay, so let's begin. To start off, we're going to use a 2911 router. So we'll add a 2911. Okay, so I'll call this 2911 ROAST. Okay, so router on a stick. So that's the first thing we need to do. We'll connect the router to gigabit Ethernet 00. We'll connect it to switch interface. Now I'm going to use port 22. Okay, I'm going to use port 22. So we'll add it to port 22. We'll go to the router. Again, I'm going to, for the purpose of this lab, skip all the basic configs. You can go ahead and configure all the basic configurations. I'm just going to change the host name to roast. Okay, so change the host name to roast. Save that. The first thing we need to do is we identify that this is the interface we're going to use. Okay, so what we're going to do here is we will create sub interfaces. So I'm going to create G00.10 for VLAN 10, and it will have an IP address or default gateway. That IP address will function as a default gateway, 172.1.10.1. By the way, you can see that I've already added this info in the last lesson. Okay, that's up here, DG for VLAN 10, 20, and 30. Okay, and for VLAN 99, you can do that. 172.1.7.99.1 could be your default gateway for native, but we don't need that. Okay, we don't need that for the native VLAN. Management VLAN, you can also add a default gateway for management VLAN. I'm just going to do that for 10, 20, 30. At least you get the idea, so you can configure the rest. But as long as your VLANs are working as expected, your inter-VLAN interfaces are working as expected. Okay, so that's going to be .30 for the VLAN 30 guest VLAN. Okay, again you can add 150.1. That's for the voice VLAN. Okay, so let's try this tree. Okay, so I'm going to create 3 sub interfaces. I'll create the interfaces, sub interfaces, and then what I will do is I'll enable encapsulation.1q. So every packet that comes here, the router is going to do tagging. It will encapsulate them with the 802.1q encapsulation method, and it will contain the VLAN information, okay, VLAN ID and all that. Okay, so that's the purpose of the .1q encapsulation, and then we assign an IP address. So it's straightforward. Okay, so we go back to the roast router, and then conf t int g00 dot, notice dot 10. Okay, it becomes you can see the mode turns into sub mode turns into sub if. Okay, sub interface. Okay, so now I'm in the sub interface G00.10. I want to add a bit of description here. Description: default gateway for VLAN 10. Okay, IP address 172.17.10.1 255.255.255.0. Okay, so I'll just expand the screen a bit and hit enter. Notice it's telling me configuring IP routing on a LAN sub-interface is only allowed if that sub-interface is already configured as part of IEEE 802.1q. Okay, so I need to add in the line that does the encapsulation. Okay, so encapsulation, just put leave a space, put question mark, you will notice .1q is there. Okay, notice as soon as I type in .1q, it does not, it tells me incomplete command because it's expecting I need to specify what VLAN. Okay, so this is 10 is for VLAN 10. Okay, so I hit enter. Okay, I'll just put in a no shut there. You don't need to do that. Okay, but when you do a show IP int brief after you've done that, you will now realize that we've added a sub interface G0.10. Notice when I added the IP address, it did not allow me until I added the encapsulation. So I need to go back and put in the IP address. So conft int G0.10 IP add 172.17.10.1 255.255.255.0. Okay, again no shut, and okay, show IP int brief, and this time you should see, okay, we have a sub interface 0.10 IP address assigned. Okay, it's at the moment still down. Okay, now the reason why you see it says administratively down is I need to turn on the interface itself, the physical interface. So I'll go conft int G00 and no shut. Okay, so that turns the interface on. So this time when I do the end, I go show IP int brief. You can see now that the sub interface is up. Okay, so the sub interface is it's a logical interface. Remember, it's a logical interface. It's built on one single interface. Now traditionally, the old method of VLAN, inter-VLAN routing, was you had to create separate physical interfaces for each VLANs, but that's not a very scalable option, because on a router you don't have that many many physical interfaces, and if you had 10 VLANs, you would end up having to create 10 ports, physical ports, which is not a very practical thing to do on a router. Okay, so that's where the roast comes in. Okay, so that's traditional method was there, but it's no longer used, and so we don't need to talk much about that. Okay, so we've created one sub interface for VLAN 10 already. I'll create another sub interface for 20 and 30. Okay, so conft int G00 dot, that's for 20. Okay, encapsulation dot 1q, this is for VLAN 20, and description default gateway for VLAN 20. Okay, with an IP address of 172.17.20.1 255.255.255.0, and I think that's it I need to do. Okay, so I'll exit. I'll go int G00.30 encapsulation dot 1q, that's for 30, description default gateway for VLAN 30. Okay, IP add 172.17.30.1 255.255.255.0, and that's it. Okay, so do a WR to save all that. Show IP int brief, and you can see that I have 3 sub interfaces for 3 VLANs. Okay, so you can see now that we have I have VLAN 10, 20, 30 sub interface created on the router on a stick router. Okay, remember that I need to go to switch 1 and configure this interface as a trunk interface. Okay, because at this stage, if I try to do a ping, it will not work, because that interface is not yet a not yet a trunk interface. Okay, so I go int fa0/22 and do a switch port mode trunk. Okay, switch port trunk native VLAN 99, switch port trunk allowed VLAN 10, 20, 30, 150. I need to add 40 as well, and 99. Okay, and WR, save that. Okay, so it will bring down the interface for a while and then up again. Okay, so this is where I need to enter the default gateway information. Again, remember, if I do a ping, it's not going to work because we need the router to do the routing, inter-VLAN routing. Okay, so for VLAN 10, its default gateway is 172.168.10.1. Okay, so I'll close that. I'll go here, saying 172.17.10.1. Okay, so you can apply the default gateway. This is going to be 20.1 for all the interfaces in each, all the PCs in each VLAN. Okay, 172.17.30.1 is going to be 172.17.30, sorry, 20.1. This is going to be 172.17.30.1. Okay, so when that is done, I'm going to click on PC5, which is in VLAN 30, and I will see if I can ping 172.170.10.11, I think. Yeah, that's in VLAN 10. Okay, so do a ping. Okay, so let's hope this works. And yes, okay, reply is successful. Okay, so this indicates that inter-VLAN routing using router on a stick functions well. So you can see now that we don't just have only VLAN 10 being able to see the PC in VLAN 10. So notice PC0 is 10.10. So I'm going to try and ping 172.17.10.10. Okay, so it can PC3 can see PC0 in its own same VLAN, VLAN 10, but not only that, it can see 20, also one in VLAN 20. Okay, so I think this is 20.20. Okay, so I'm pinging the wrong. Okay, I pinged the wrong IP address, so it's timing out. It should be 20.20. Okay, so I'll try 20.20. Okay, notice the reply is successful. Okay, so that confirms that we have managed to configure router on a stick correctly. So we created sub-interfaces on the physical interface, logical sub-interfaces on the physical interface G00, and we created sub-interfaces for each VLANs, VLAN 10, 20, 30. If you have voice traffic, again you can create a voice VLAN 0.150 specifically for voice traffic. Okay, so that's using router on a stick. Okay, so what you can do is you can pause this video, try to go over your notes, read through, look at the configs again, just to make sure you understand well what we did here. I'm going to take the router out, and then I will add a multi-layer switch. Then I'll move on to the next part of our video, which is configuring layer 3 switch for inter-VLAN routing. Okay, so this is one option to use. Roast is okay. The problem is that it can't scale beyond 50 VLANs. Okay, so when you have a network environment where, or a deployment where you're going to use a layer 3 switch, this is when you need to now move into multi-layer switching. Okay, so I'll take this router out. I'll just remove the link first. Okay, notice I'm going to still use the same interface, port 22. I'm just going to remove the router, place it here, and I'll click on network devices, go to switches, and you'll see we have two types of switches, multi-layer switches. It's the 3560 and 3650. Okay, I'm going to use the 3560, so click on 3560. Notice it's a multi-layer switch, so I'll call this one MLS. Okay, MLS multi-layer switch. Okay, we can say MLS or dash L3. Okay, layer 3 switch. So we'll add the switch. Another thing you have to notice here is that with routers we used sub interfaces. With layer 3 switching, layer 3 routing, we're going to use virtual interfaces, switch virtual interfaces, or SVIs. That's what we're going to use. For WAN purposes, you have to change the port from an access port into a routed port. Okay, so this is what we're going to do. We will add a connection from switch 2. I'm using the same interface I used earlier on, port 22, and on the switch I'm going to use port 22 also. Okay, just use the same interface. Okay, so I don't have to worry about switch 1. I've already configured that same interface. Now I need to focus on the multi-layer switch, layer 3. Okay, so the first thing we need to do here is, again, you can do all the basic configs required on a switch. Okay, I'm just going to configure the host name to MLS L3. Okay, that's the host name I'm going to create, and that's all I need to do for now. And the next thing we're going to do is, because we're using interface FA022, we go to that interface. Okay, now remember that this interface is going to do routing. Okay, remember it's going to do routing. All the traffic is going to come from here to the layer 3 switch, and the layer 3 switch is now going to act as a router. Okay, so that interface needs to be a routed interface. Okay, it needs to be a routed port. Okay, so int FA022. Okay, the next thing you need to do is no switch port. Okay, no switch port, and that turns the interface on. So now we'll change it from a switch port, an ordinary switch port, access port, to a routed port. And then we assign IP address. Okay, now by the way, when I type an IP address here, to add an IP address, I don't really need to create an IP address here again, unless my switch is connected to a internet connection or to another router that I need to connect to for WAN purposes. Okay, and that's what we did here, routed port. What I really want to do here is, I'm just going to create SVIs only. Okay, SVIs, not sub interfaces. I'll be creating switch virtual interfaces for each VLAN. Okay, so I'm going to go ahead and just exit first. Now go Inter-VLAN 10. Okay. By the way, just before I move further on, I'll just do an end here first. Show VLAN brief, and you can see here that you see we also have the default VLAN, VLAN 1 plus the VLAN 1002 to 1005. We need to have the same VLANs also in this switch here. Okay, the same VLANs I'm referring to, the VLAN 10, 20, 30. So we need to create those VLANs first. So VLAN 10, name is going to be faculty. Okay, VLAN 20, name will be student. VLAN 30, name is going to be guest. VLAN 40, name is going to be management. VLAN 99, name is going to be native. Okay, and I'll just add VLAN 150 also, or maybe no need for that in this case. And that. Okay, go conf t. Okay, now I need to add SVIs. Okay, meaning we've already created the VLANs, we just need to assign IP addresses. So int VLAN 10. Okay, same addresses I'm going to use, the default address, default gateway addresses. Int VLAN 10. You can go ahead and add description. I'll just type in DG, default gateway to VLAN 10. Okay, IP address. Notice same thing we did with the router, but this time it's SVI instead of sub interface. 172.1.7.10.1, 255, 255, 255.0. Okay, no shut there. Okay, so that's the VLAN 10. I will need to exit, go int VLAN 20. description dg to VLAN 20 IP add 172.17.20.1 255.255.255.1 sorry .0. Okay, it's already been turned on, so I don't need to do a no shut. Exit int VLAN 30 description dg to VLAN 30 IP add 172.17.30.1 255.255.255.0, and that's it for VLAN 10 20 30. And I think that's all I need to do here. One more thing I need to do is you look at these lines here, switch port, mode, trunk. These are required if I'm going to allow trunking to happen. If I'm going to allow for trunking to happen from port 22 to port 22 on the layer 3 switch to port 22 on switch 1, I need to configure this part. Okay, make that interface switch port mode trunk native VLAN 99, and then allow the encapsulation also. Okay, so that's on port 22. So I'll go back to port 22, conf t int fa0/22 switch port mode trunk. Switch port mode trunk. Okay, switch port mode. Okay, just leave a space there. Okay, do you notice what's happening here when I type switch port mode and I put a question mark, or when I type trunk it did not recognize the command switch port mode. Do you notice why that's happening? You remember earlier on I went ahead and that interface I configured it as a no switch port. Okay, so basically what I did was I just turned that interface into a routed port. Okay, so I need to go back and type no. Okay, okay, so what I need to do on that interface is basically because I type no switch port, all I need to do is just type switch port and hit enter. It will turn the interface from a routed port back into a switch port, and that's when I can type switch port mode trunk. Okay, can you see what's happening here? It's telling me command rejected, and interface whose trunk encapsulation is auto cannot be configured to trunk mode. Okay, so what I need to do here is switch port mode trunk encapsulation dot 1q. Okay, so that's what it's telling me. Okay, switch port mode trunk. Let's leave a question mark there first. Okay, switch port. Okay, I'll just leave that part. I'll go straight to switch port trunk native VLAN 99. Okay, so there needs to be a match. Switch port mode trunk. Okay, an interface whose trunk encapsulation is auto. Okay, so I need to type in, just put in a quick question mark there. I need to see what's going on here. Let's do a switch port. Okay, so switch port trunk encapsulation question mark. Okay, I think I made a mistake there typing in switch port mode. Switch port trunk encapsulation dot 1q. So I'm going to change that again, switch port mode trunk. Okay, so now we don't get that. Okay, so again, notice what I did here. I'll just do a quick recap. Earlier on I set interface FA022 to a routed interface by typing in no switch port. Now I did mention that you only need to do that if that interface, particular interface, is connected to an internet connection or to a router that will allow for routed traffic. Now here you will notice that we don't need to do set this as a routed interface. It's connected to a switch, okay, and this end is a trunk interface, so this end also needs to be a trunk interface, and that's the reason why we went back to the interface, and we had to disable these by typing switch port, just switch port only. Hit enter. It turns the interface from a routed port back into a switch port again, and then we went ahead and typed switch port mode trunk, which asked us that it cannot be set to trunk if it's on auto. So what we had to type in was this line here, switch port trunk encapsulation .1Q. So we forced the encapsulation to .1Q, and then we set it to a trunk port. We set the native VLAN to 99. Okay, that's what we did here. Okay, and we also created SVIs for the 3 VLANs. Int-VLAN 10, we assigned the default gateway address, and then did the same for VLAN 20 and 30. Okay, so the last thing we need to do now, here is turn on routing. Okay, now why we need to do that? If I type end there and I do a show IP route, you will see that default gateway is not set. Okay, because I need to type in that last command there, IP routing. Okay, then that enables routing functionality in this multi-layer switch. So conf T. So what we are doing here is we are now enabling not just switching only, we also want this router to do routing. Okay, so that's all, IP routing, and do a show IP route, and I should expect to see this tree. So that's what we needed. Okay, VLAN 10, 20, 30. Okay, so again, let's test. Let's go back to PC3. From PC3, I'm going to ping, let's say I will ping PC2, which has an IP address of 30.30. Okay, so ping 172.17.30.30. Okay, so again, fingers crossed, hopefully this works out. To request timing out. Okay, so if that happens, you do a troubleshoot, you find out why. Okay, so troubleshooting is the last part of the lesson notes. When you read through the lecture notes, right at the end is troubleshooting. Again, you can have a look at that, but for our case here, everything seems to have worked out well. We were able to configure Inter-VLAN routing using a layer 3 switch correctly. So notice the last two replies are successful. Okay, so that's a good sign. Okay, so notice PC3 is in VLAN 10, but because this layer 3 switch is able to do the Inter-VLAN routing, PC3 on VLAN 10 is able to communicate with PC2, which is in VLAN 30. Okay, so I think that brings me to the end of this video. The key point here that you need to pick up from this lesson is that there are two main types of Inter-VLAN routing. That's router on a stick or roast, and you have layer 3 Inter-VLAN routing using a layer 3 switch. And between those two methods, they have their advantages and disadvantages. It depends on what type of setup you want to have. That will help you determine which you should use. Okay, usually smaller networks, you might want to use roast, but when you have larger networks, campus LANs usually will implement layer 3 Inter-VLAN routing. The only disadvantage you'll find with the layer 3 Inter-VLAN routing, as mentioned earlier on, is because of the expense involved in the layer 3 switches. Otherwise, that's a more preferred method to use because it's much more faster compared to router on a stick. Okay, so have a look at the packet tracer file. If it means you can do this again and again, try to do some variations in there just to help you understand how this works. I put up a challenge for you on on the NetAcad site. I'll just show you here. That's the challenge. I have an article I put up some years ago on my blog site. Oh, the link is not working. Oh yeah, internet is out. Okay, so I put up a link to my blog site on a VoIP, and there's also another resource I uploaded, a short tutorial I added on VoIP. And it's an optional lab, you don't need to submit it, but this is something we will do during our boot camp. Okay, so at least if you're going to do this, you already practiced it using Packet Tracer. Okay, so that's part of applying the idea of using VLANs. So you separate the data traffic from VoIP traffic, and then you use a router, configure it as a Call Manager Express CME, and then you try to VoIP. Okay, so I'll see if I have time. I might be able to do a separate video on that to try and demonstrate it. But that's not the main focus of this topic. The main focus of this topic is to learn about Inter-VLAN routing. Okay, so again, your lesson 4 PT file is there, lecture notes are there. Once you watch this video, have a look at the lecture notes. Also take a look at the PT file, and then they will help you to understand the key concepts in this lesson. That's it. Thank you.